Welcome back, everybody. We're going to be focusing on inequalities, linear inequalities, graphing, and figuring out whether ordered pairs are in fact solutions. On this first one, we have 5 choices here. Which ordered pairs are solutions to 2x plus y greater than -4? First coordinate is x, second coordinate is y. So one at a time, we're going to plug these in. I'm going to put a -3 in for x. I'll put a 0 in for y. I'm going to see if that's greater than -4. Well, 2 times -3 is -6, and we're basically asking, is -6 greater than -4? And that is a false statement. That is untrue. F for false. This one definitely does not work. Let's look at the next one. 4, -12. I'm going to put a 4 in for x and a -12 in for y. Is that greater than -4? Alright, 2 times 4 is 8, and 8 minus 12 is -4. And basically now we're saying, is -4 greater than itself? That's an untrue statement, so B does not work. Now we'll go try C. Putting a 0 in for x and a 1 in for y. Now we're asking, 2 times 0 is 0. 0 plus 1 is 1. Now our inequality is 1 greater than -4, and we say yes, that's a true statement. C does work. Alright, let's look at D. -1, -1. 2 times the -1 plus -1. Is that greater than -4? 2 times -1 is -2. -2 plus -1, -3. -3 greater than -4? Yes, it is. True statement. D works. And then finally 5, or 5 comma -12 for the last one. 2 times 5, -12. Greater than -4. 2 times 5 is 10. 10 minus 12 is a -2. Is -2 greater than -4? Yes, it is. So we actually have 3 true statements. 3 of these ordered pairs make the inequality true. I'm going to look at another one here, but I'm going to use the website Desmos, desmos.com/calculator. I'm just going to use it to graph y minus 2x less than -3, and then I'm going to plot all 5 points, and any points that are in the shaded region or on the solid line solve the inequality. Let's have a look here. Desmos. Okay, here's our inequality, and you can just type it in, desmos.com. Type it in just like I did here. I'm going to click on it. There it is. That's what the graph looks like. Notice it's a solid line meaning if a point lies on the solid line, it does solve the inequality. Also, it's if it's in the shaded region. So -6, -3, you can see that there. Notice it's in the shaded region. It does not fall in the shaded region, so it does not solve the inequality. Here's 0, -2. We can see that right here. Again, falls outside of the shaded region. Here's 1, -1 on the line, so it works. And then 5, -3, we can see that. There it is over here. That works. And then finally 7, 12. Zoom out a little bit or move up to see it. There it is. It falls outside. So the ones that solve it, 1, -1, 5, -3. I think that was choice C and D. There we go. You can use Desmos to see whether points solve inequalities. Okay, the next one is a story problem, and we're just going to set it up. And the key of this one is looking for a phrase to determine what the inequality symbol should be. Notice all our choices are the same except the inequality symbol. Kendra's making a large salad for a party. She buys lettuce at $2.25 a pound and tomatoes $2.65 a pound. She spends at least $8. Let X represent the number of pounds of lettuce that Kendra buys. Y represent the number of pounds of tomatoes. Which inequality represents the situation? We're not solving, we're not graphing. We just want to identify which one solves the inequality. And here's what we're looking for. The phrase at least. When we see at least, when you see the word least, you tend to think lower, less than. But no, at least actually refers to greater than or equal to. Greater than or equal to. And $8. Looks like I have a typo here. This is not the right one. So we're going to set this up. Let me just white this out here. And then I will type the right one here. All right. So let's get this inequality set up. So 2.25 for tomatoes. Adding to that the 2.65 times y for lettuce, and it needs to be greater than or equal to 8. There's the inequality we want. Let me add one little thing here. There's the little line saying equal to. There's our inequality, because yeah, the ones I was showing earlier were a typo, they weren't right. 2.25x plus 2.65y greater than or equal to 8. That means at least 8. The lowest amount could be 8 or higher. All right. So there's the setup. All right. Let's look at another one here. Just graphing. Now a little primer on graphing inequalities. Okay. So generally when you graph inequalities, you want slope-intercept form. You can graph it just like a normal line where b is the y-intercept and m is the slope. And in equations we have an equal sign. However, with inequalities, what's going to be substituted for that equal sign is a inequality. So in here could go one of the four inequalities: greater than, less than, greater than or equal to, less than or equal to. Alright, now when graphing, if it's greater than or less than, it's going to be a dashed line. If it's greater than or equal to, less than or equal to, it'll be a solid line, meaning the solution could fall on the line. And then another way to look at this with whether to shade above the line or below the line is greater than or equal to. If you see both of those and you're in slope-intercept form, you definitely want to shade above the line. However, if you see less than or equal to, you want to shade below the line. And I'll show this, working this by hand. We'll also show this with how Desmos will find it for us. Alright, let's check it out here. Which graph represents y less than 1 minus 3x? Well, let's rewrite this in slope-intercept form. I'm going to put the negative 3x first, and then the plus 1, and then so you can sort of identify slope-intercept a little better there. See how everything kind of lines up. mx plus b. Alright, that tells us a y-intercept happens at 1. We have a y-intercept at 1. We have a slope of negative 3, which negative 3 over 1 means go down 3 and to the right 1. That's how the line slopes. That's how it slants. We have a less than symbol, which means we shade underneath the line, and we have a just less than, meaning it's going to be a dashed line. So it's either going to be one of these two. Let's first double check to make sure we have this plotted right. Okay, we want to cross at 1. Notice all of these cross at 1 on the y-axis. And notice they all seem to go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. Alright, so the structure of the lines looks the same. We need to choose the one that's a dashed line, which is one of the first two. And then we also need to say shade below the line, given that it's a less than symbol. Looks like this second choice is going to satisfy everything. Dashed line, shade below. So we got all that. Notice all four choices here. the line structure itself was the same, but we were just focusing on this one inequality here. The inequality symbol less than means shade below the line. Less than also means it's a dashed line. If this was a less than or equal to, we would have chose the second one. If this was greater than or equal to, we would have chose the fourth one. And if it was just greater than, we would have chose the first one. All right, let's switch over to Desmos and have a look at this one on the graph. Let me uncheck the ones we just did and uncheck the labels so we're not distracted. And here is that inequality right there, y less than 1 minus 3x. I can type it in. Desmos allows us to type it in nicely. Let me just click on it, and there it is. We see that. If we want to see the number 1, see how it crosses at 1, see how it's a dashed line and shading below. So Desmos does all this for us. Makes life a lot easier. All right, now let's talk about special lines. Special lines, I like to call them special lines, come in two flavors. We have horizontal lines, looks like this. We have vertical lines, look like this. The vertical line goes up and down, the horizontal lines left and right. Okay, horizontal lines just have a y in the equation. Vertical lines just have an x in the equation. Okay, and so the exact format is going to be x equals some number, and the number that it is wherever it crosses the x-axis. For horizontal lines, we're going to have y equals a number, and that number is where it crosses the y-axis. So why don't we mess around on Desmos a little bit just to kind of see this in action here. All right, I'm going to go down here. I'm going to say y equals 2. Notice we have a horizontal line passing through 2 on the y-axis. Say I wanted to make it negative. It would be down here at the bottom, a -2 down here underneath the x-axis. All right, let's do another line. Let's say x equals 4. X equals 4. That's a vertical line. Notice it's passing through 4 on the x-axis. And let's do another one. Let's do x equals -1. And notice now we're passing through -1. Okay, so now we've gone over the different vertical and horizontal lines. Let's make them inequalities. Let's see what happens here. How about y less than 3? Y less than 3. Well, dashed line, and notice everything below 3 was shaded. Same thing as if I did greater than 3. Now it's above. What if I did greater than or equal to? It would be a solid line. And if I did less than or equal to, it would be a solid line there as well. So there's horizontal lines. Hey, let's look at vertical. X greater than 1. Crossing here at 1 on the x-axis. Notice it's a dashed line. What if I did x less than 1? Dashed line, shade to the left. So notice the x we have left and right instead of up and down. If I did less than or equal to, it would be a solid line. And if I did greater than or equal to, notice it's now a solid line. All right. Look at an example here. Let's try to figure out the right shading here. We can probably get this just by looking at it. Notice what we did previously. Vertical line, dashed, and since it's less than symbol, we're going to shade to the left. And the one that works here is this right here, x less than 2. Let's go back to Desmos to verify that. X less than 2, I have it right here. Click on it. Notice we're at 2 on the x-axis dashed line, and we shade to the left. All right, thank you very much for watching. Hope this helps.